All right, hello everyone. Welcome to August 3rd, 2022 meeting of SIG-Auth. Let's kick it off. We have one item on the agenda. Let's get started. I'll share my screen unless Jim, you want to share your screen actually?
So Hokil was going to do the demo, so I think it may be best if he shares, and we'll just quickly go through the linked markdown file first. And
y'all should have access to share screen, so go for it.
Hokil, do you want to pull up the markdown, or would you like me to share?
Maybe you can do that. I have a problem with my monitor. So
Oh,
yeah,
okay.
I would just
No worries. All right, let me pull that up. Okay. Yeah, so just quick context and background, and then I'll hand off to Hokil for the demo itself. So what we wanted to demonstrate and get some feedback and discuss is a feature we're planning to put into Kyverno around pod security admission and integrations with, right? So I think most of the folks probably have already heard or have some background on pod security admission and some of the trade-offs related to it, which were discussed in quite a lot of detail during the design. And of course, there's feedback from users in the community as well, right? But what we were trying to figure out is with pod security admission now being enabled and the default implementation, what could we do as, from a policy engine perspective, for both, policy engine and pod security admission to work well together. So the idea would be, and the guidance I think that's typically given to users is if, the default pod security admission cannot handle all of the use cases that are required, then, use something like Kyverno or OPA Gatekeeper for more finer grained control. But how exactly that happens and how the two can work together is sort of left up to as an exercise, either to the users or to the policy engine implementation. So what we were trying to do with this feature and what Hokil will demonstrate is just showing how in Kyverno, just integrating with pod security admission, is there a way to easily address some of the concerns and issues raised by the community, mostly around the finer grained exceptions? And that's where the new policy construct that we are proposing is something like this, where Kyverno already has like validate, mutate, generate rules. The new rule type here would be under validate for pod security, and it would follow the pod security standards as well as the profiles related there. And internally, the implementation of this rule type will reuse the library created for pod security admissions. So the idea would be to then specify the profile level required and then have finer grain exclusions or exceptions which the user may want to configure. So that's kind of a brief summary of what we were trying to achieve. And I think we have a working implementation we are looking at, but maybe I'll pause there and see if there's any questions or thoughts or feedback, or if Chip and Hokil have anything else to add.
No, I think it's good. So if you don't have any questions, I can go through the demo.
Okay.
Okay, let's go. So tell me if you can see my screen with the terminal and then VS Code.
We can, yes.
Okay,
you
good.
might want to increase the point size just a little bit more, though.
Like this?
Yeah, and in your editor if possible. It's pretty close, but maybe just a little bit would help.
Okay. Okay, good. So yeah, so I'm working on this feature on extending the pod security admission as part of the LFX mentorship. So I have a little demo to show you. So for the sake of the demo, I have already created some namespaces, so I will show you that. So the first one is the staging PSA baseline with Kibeno namespace. So what I did basically is just I enforced the baseline PSA on this namespace for the 1.24 version. And later on, we will apply a Kibeno policy for final grade control. And we also have another namespace where we enforce the restricted PSA directly. So if we look at the pod on the right here that we want to create, basically, if you go through the manifest, we can see that we don't drop all the capabilities. So if we try to create this pod on the namespace where we enforce restricted, of course, it will be forbidden, right? So we'll try that, apply, next. And so we'll try to create that on the namespace where we have the restricted with the Kibeno. And of course, it's forbidden, and it tells us that it violates the pod security because we didn't drop all the capabilities, right? And so now we will look at the Kibeno policy that we have on the left here. So reduce the size here. So what we do here is that we want to, since we already have the baseline on the namespace, we want to apply the restricted level for all the pods that are running on this namespace. And we want to exclude this control, the capabilities restricted, for all the containers that are running with Nginx, right? So if we try to create this pod, what the policy will do is just that it will exclude and ignore all the errors or the check results regarding the capabilities drop. So we'll try to do that. The first thing, we have to apply the Kibeno policy. And after that, we'll try to create the same pod. With Kibeno. And you can see that the pod was created because we excluded this particular control for all the containers running with the image Nginx. And this is the case. Do you have any questions until now?
Let me just clarify a little bit for the viewers here, Hyokyo. So you notice that the control name field, rather than asking users to know precisely which fields are codified in the upstream controls, we're giving them helpful names that we put under control name. So capabilities underscore restricted. Kyverno understands all of the fields that are required in order to satisfy that control. And so it reduces the burden on users to have to go and look at upstream controls and key all the fields in, make sure that they're the right type, et cetera, et cetera. Now, Kyverno will allow that to provide even more fine-grained control. But in this way, just by specifying a handy string, of which we would obviously provide the list of the control names, and they would be a one-to-one mapping to the PSS controls, it allows users to quickly and more easily exclude if the level of granularity just needs to be the control itself and something like an image. They don't have to go and put all the fields in. They just reference the name, we understand what all the fields are, we make the exemption. If they need more fine-grained control, they can specify, and it's not shown here, another field which shows exactly which fields will be exempted.
Yeah, thank you. So maybe if you don't have questions, I can show you another demo, maybe.
So if I understand correctly, this is letting you apply the existing pod security standards, but giving you finer grained control over which specific standard controls are enabled and letting you exclude specific pods or workloads from it. Is that right?
That, or also giving you the ability to make alterations to the fields that are part of the control. So for example, if one control said, and many of the controls are applicable for containers, init containers, and ephemeral containers. Let's just say for demo purposes that you wanted to ensure that the control was enforced for all containers, but maybe you wanted to relax one of the checks, maybe for this drop control for just init containers. You can get that granular, and it'll only permit that if the image and the init container passes that check, but enforce it for everything else.
Got it. Thanks.
So Hyokil, would you like to do another demo?
Yeah, sure. So in this case, as Chubb said, if we specify only the control name, it will exclude all the restricted fields regarding this control. So the second demo that I have here, so in this one, we have some other fields. So in this policy, we want only to exclude the restrict field that we specify here. So this is security context capabilities as, so we want to exclude only this field. And we can also specify the values that we want to exclude for this specific field. So in this case, sysadmin. On the right, this is the pod I will try to create. And as you can see, we have the sysadmin value on the capabilities that, and normally if we don't exclude any values for that, it will be forbidden. So let's try to do that. Just apply the Kubernetes policy, and we'll try to create the pod right now. So in this namespace, I only have Kubernetes. There's no PSA activated. So you can see that the pod was created, and imagine that I would delete the pod. Imagine that I put something here, another value, like, I don't know, system maybe. I'm not quite sure about that. And we try to create that. Normally, it would be forbidden, right? Yeah. So we have a message here. So this is not well formatted for the time being, but it says that we have the sysadmin and system on the capabilities at values, and we have to exclude all these here system. Hopefully we will apply the policy, and we try to recreate the Kubernetes. Yeah, the pod was created because we excluded all the values here. Do you have any questions?
And any feedback on this as well? I think a question was raised in SIG-Auth channel to solicit some feedback and some criticism on this, and I don't think that we saw one response. So it would be good to kind of understand, is this, do people see this as beneficial, valuable? Do you see obvious holes in it, problems? Curious for any and all feedback.
Tough crowd.
All right, well, let me just ask, I guess, an easier question. Does this seem like a good idea? Do you all see that there is that this fills a gap that would be naturally felt by those who wish to use pod security admission?
I think my concern with this approach is it seems like it's mostly used for it seems like it would be most useful for punching specific holes in the policies, which was something we put a lot of thought into when designing pod security admission, and explicitly didn't want to do. A lot of weakening the standards in specific ways requires a lot of expertise and knowing what those, like, what the details of what those restrictions are doing in the first place. And I'm worried that people are going to be inclined to say, well, you know, I know I need this one piece and my container is not running, so I'm going to you know, just punch this one hole in the standard to get this container running without really understanding the implications of that.
Yeah, that's a fair criticism, and that's something that, you know, we're also concerned about. Obviously, you know, when you provide capabilities such as this and many other things that are in the purview of external admission controllers, there's always that possibility. And it's kind of a caveat emptor moment where, you know, if you're going to buy a knife, you know, we can't necessarily provide a guarantee that you're not going to cut yourself with it. But at the same time, there are many legitimate use cases for where, for example, users have to use, because of one or multiple reasons, a certain vendor's product or a certain upstream tool, and, you know, they're behind in ensuring that they're adhering to the latest guidance. I mean, we all know that just happens in real life, and so in some cases there are cases where they need to punch those holes through. But it's not because, hey, I have an admin who built a container and we really aren't keeping tabs on what he's doing with it, so we're going to just go ahead and trust that's fine. I think that's the more minority use case than saying, you know, I have to run Istio or pick a tool. I'm not necessarily biased towards that, but I have to run X tool, and, you know, they're working on providing these capabilities, but as an organization, we need to turn these controls on now to cover the 98% of workloads that we control and we run. And you know, we're diligent about ensuring that those things adhere to, you know, best practices that pod security admission codifies. But this other 2% where we have to rely on these ecosystem tools or these vendor products, like, we can't really control that, but we still need those to run. So, let us be very focused on the holes that we punch so that we only let those vendor or ecosystem tools through, and not just anybody who wants to run, a container without, any of these field sets. So I think that's the goal, and that's kind of that's what we see quite often in the community, is people asking and having use cases for how to make those strategic exclusions based on the tooling that they need to use, which really isn't the same as their internal workloads, just that they're too lazy to control and provide oversight for them.
Yeah, that makes sense. I just think it's hard. I definitely understand the use case and the motivation. I think it's hard to get it right. So for example, if you're excluding the Nginx image, I think the standard Nginx image is built on, I don't actually know what the base image is off the top of my head, but I think it's got a full shell in there. So you could say, run the Nginx image, but for the command, don't actually run Nginx, run a shell script that I'm going to give you. And so that's the sort of piece where you need to kind of, to really do it safely, you need to have some fixed combination of the image, ideally the image kind of tag and version, but also the command line that image is executing, lifecycle hooks, probes, think about sidecars and restricting ephemeral containers, and think about how exec permissions are going out. And so it kind of like quickly bubbles up into this sort of difficult case.
Yeah, and those are all good points to mention. I'll just call out that all of those things are possible to restrict today with something like Caverno. Obviously, there are other things but for example, Caverno has the ability to reach in and look at container metadata and do exactly that. So
yeah,
it's not that this would be the end-all rule for anything having to do with security around containers. It's that specifically for poking holes in pod security admission, this would be potentially useful, but that it wouldn't obviate the need for you to do things like, for example, making sure that you actually can't pull Nginx, like it needs to come from your internal registry, corp.org/Nginx-gold or something. So that, that would be the image name that you could put here. And then you might have another policy that just totally forbids pulling images that don't come from Docker Hub, or totally forbids use of a latest or a non-specified tag, and even going so far as to say you must have an immutable digest. So those are all additions that can be used to fortify and protect against those angles. And in this, we're not trying to use one new rule type to try and obviate the need for all those. It's just that this fills an additional gap, but you still need these other things to provide for those other guarantees. And this works perfectly well, by the way, with those others. It's not like, it's an either or thing. So this is just another validate rule. And there's nothing whatsoever to prevent another validate rule from saying, nope, we said that the policy author said it was cool to run Nginx. And so that was allowed. But then another evaluation said, no, you actually can't run Nginx. It has to be from corp.org registry. And so we're going to deny the request. So they're additive in nature, and one can't countermand the directive established by another.
Yeah, that makes sense. Thanks.
Yeah, I think the other thing we were trying to figure out while designing this type of policy rule is what would be the alternative, right? And it seemed like the only other alternative would be to turn off pod security admission and just completely fall back to an admission controller like Caverno or OPA Gatekeeper, which didn't seem quite as nice, right? So it seemed like you still want to leverage pod security admission, at least for a baseline, and then use finer grained exclusions or exceptions as needed in the right areas. So that's kind of what we were trying to design for.
Yep.
So one quick note on the implementation, and maybe Hiroko has more information on this to add in, is currently we are using the library itself directly in Kyverno. And if I recall correctly, Yokil, there were some questions and discussions around the return types. And I think you had asked that on one of the channels too, right? So is there something that we want to kind of discuss or propose on that?
Yeah, so we are using the PSI library to get the check results, and we saw that the return message is not formalized. So in the case where a control name is forbidden, it would be nice to have all the forbidden values so that we can pass it more easily. Because for the time being, it's just in the forbidden detail message, and it's pretty hard for us to pass it.
So is that something, you know, that, and happy to, of course, create or get a PR created for that. But yeah, maybe we can discuss this a little bit more offline, but that was, yeah, just the one challenge that we encountered when using the library.
Yeah, sure. So maybe I can show you.
Sorry, just a follow-up question on that. There's the forbidden reason, which should be like, that's maybe not formalized in terms of there's consts that you can compare it to, but those should be more machine readable. Are you saying that the details of like which specific field violated it or which values violated it are what you'd like to get access to?
Yeah, right. Maybe I can show you the message I posted on the Slack. So if you can see my screen, the Slack.
Yeah.
So for the time being, what we have, so we have the allowed, forbidden reason, and the forbidden detail. And the thing is that it would be nice to have, you know, another object inside the check result where we would have an array of all the forbidden values, and maybe also the restricted field, because when you see now here, it's pretty hard to pass it, right? To get all the forbidden values and the restricted field.
Yeah, that makes sense. If you want to file an issue in Kubernetes,
yeah,
we could consider that.
Okay, nice.
So Tim, is that something that you all would potentially be amenable to if we just went ahead and also created a PR to try and assist on this area, in addition to the issue, of course? But do you think that would be, does this sound like something that the SIG-Auth would be amenable to accepting?
Yeah, I think so. I think we'd want to discuss it a little more. And so that's why I'd suggest opening the issue first with some examples. And
okay.
But yeah, if other folks in the org are open to it, definitely we welcome a PR for that.
Okay.
Also, since this isn't like end user facing, it doesn't touch the Kubernetes API at all. I think I don't think we would need a KEP process for this. So just straight to PR would be fine.
Okay. All right. Great.
Well, anything else that we want to show or discuss here, Jim or Hyokil or anyone else?
No, I think we've covered everything. Yeah, certainly happy to get more feedback or questions or thoughts if folks have.
Okay.
Thank you.
Thanks.
Thank you all.
Thank you.
Thank you.
Thanks.
All right, I think that's the only item on the agenda today. So if there's nothing else, I think we can end this call today. Thanks, everybody. Have a good one.
Thanks.
Bye-bye.
Bye.